Now let's discuss functions written symbolically. Any equation in which we have the variables x and y defines a relationship between those variables. Not all equations define a function. To determine if an equation defines a function, we need to solve for y, because functions indicate the output as a function of the input. So y as a function of x. Let's try to solve for y in a few examples. Solving for y just means we're going to get y by itself on one side of the equation, and then x and all the other terms on the other. So let's take a look at example 1, and I'm going to move over here to the side. Y minus x squared equals 2. I need to solve for y, so I will add x squared to both sides so that I get y by itself. Y equals x squared plus 2. Since I have one single output, y, equaling an expression that has x in it, this is considered a function. Every input for x will give me exactly one output, y. And sure enough, solving for y in terms of x gives us y equals x squared plus 2. This equation then defines the rule that gives us one value of y for each value of x. Therefore, y is a function of x. Let's take a look at example 2 over to the side. For example 2, we have x squared plus y squared equals 4, and we want to get y by itself. So we'll subtract x squared first. And in this case, in order to get just y, we need to take a square root. But here's where we have to be really careful. In an equation, when we introduce a square root to solve for something, we need to make sure to get all of the possible answers that we include a plus or minus on the square root. Here's what I mean. Let's take the number 9. If 9 equals, let's do 9 equals c squared. In order to solve this equation for c, from what we learned before, we need to have this equation equal to 0. So we would subtract 9 from both sides, and then factor. When we factor, we end up with 2 values for the answer for the equation. Another way to consider the same equation is to take a square root of both sides. When we introduce a square root, now remember, this is the same equation, right? I need to make sure that I get both answers. Well, if I take a square root and I don't include a plus minus in the front, I only get the positive solution. I only get the principal root. So when I introduce the square root in an equation, I have to make sure I have a plus minus in the front so that I get both solutions. The same thing's going to happen over here with my expression. Y squared equals 4 minus x squared. When I take a square root of both sides, on the side that I'm not solving for, I'm solving for y. So on the other side, I'm going to introduce that plus minus. I'm going to attach the plus minus to my introduced square root. When I do that, y equals plus or minus square root 4 minus x squared. This is really important because y is positive 4 minus x squared or y is negative 4 minus x squared. I have 2 outputs for one value of x. This is not a function because I have 2 outputs for one input. Function notation is a way to name our function. So remember that a function is a rule that assigns exactly one range value to each domain value. If we have a rule, then we can use what's called function notation. We can either use y to represent the function, or we can use this notation f of x. We read this as f of x. This is not f times x. We are not multiplying the x by f. Y and f of x mean exactly the same thing. The reason that we introduce this x part is because if we wanted to plug in a value, if I just use this 9x plus 3 here, if I wanted to plug in a 1, so plug in a 1 for x, I can see that 1, 12 is an ordered pair for this function. The input shows up in the name, and the output is what I get when I finish calculating. So again, the value over here on the side, the f of x part, this is not multiplication. Please be aware of that. If it bothers you and you're afraid you're going to mess up and forget and turn it into multiplication, everywhere you see an f of x, just write a big ol' y on top of it. Just go ahead and write a y on top. Everywhere you see an f of x, just write the y. It'll help in the long run. Know that if you are headed up into college algebra, trigonometry, and calculus, you're going to see lots more of functions, so you'll have a lot more practice with it. When a rule of a function is given, we can use that rule to find the output when we have an input. This is called function evaluation. It's pretty much what I did up there with the 1. Suppose a function f is given by the equation f of x equals 2 minus 3x. 2 minus 3x is the rule for the function. It tells me how to take the input x and turn it into the output y, or the output f of x. We also call this the value of the function. F of x's value is the output. So let me walk you through this example of using the function f of x, 2 minus 3x, to find the function value at 5. So I have the function 2 minus 3x, and I want to find the function value if x equals 5. X equals 5 means instead of x in the function, I'm going to replace the x with the 5. So in the original function rule, wherever I saw the x, I'm going to replace that x with a 5. I like to use parentheses because the parentheses here, where x used to be, is going to help me with the multiplication, with signs, making sure my signs are correct, and so forth. Remember that mathematics relies on that attention to detail. So take your time, make sure you've got all the things in place, try not to rush through it, and pay attention to that detail. So on the left side, this is just a name of the function. We are not multiplying by 5. We are taking the x and replacing the x with 5. So 2 minus 3 times 5 is 15. 2 minus 15 will get me negative 13. Negative 13 is the value of my function at x equals 5. This idea of function notation isn't limited to just one number or one letter. We could look at this function of smiley face, 2 minus 3 times smiley face. We could also look at it as a function of star plus heart, 2 minus 3 times star plus heart. Wherever I had the x originally, I replace the x with whatever's on the left side hanging over with my f name. Again, we'll practice more with this. All the rest of the semester will be for practicing with function notation. And that walks us through exactly this example. Notice we have f of 5 equals negative 13. We also have y equals negative 13. Remember, f of x and y are equal to each other. We'll take a break right here. When we come back, we'll do a quick concept check. You can try this on your own. I'll have the answers up at the beginning of the next video so you can check them. We'll work through problem number 2 where we're evaluating the function at different values. And then we'll keep going learning about these functions.